everyone. This is a video on features of graphs of functions. This is in case you missed our lesson earlier this week on how to find different features of graphs of a function that we may see in class. Go ahead and present, and let's go ahead and take a look here. Okay, so first thing we want to go ahead and take a look at is here's everything you need to know. It's going to be on page 81 in your Springboard books. Here's everything we're going to be seeing in this presentation here, starting with the vertical line test and going all the way down to extrema. Okay, everything in between, we're going to cover all these concepts, and then we will explain what each one of them mean. Let's go ahead and get started with the vertical line test, though. Okay, I'm going to turn on my laser pointer. Let's go ahead and get started. So when we apply the vertical line test to a graph, we're going to use this word problem to help us out here first. So it says roller coasters can be scary but fun to ride. Below is the graph of the heights reached by the cars of the Thunderball roller coaster over its first 1,250 feet of track. The graph displays a function because each input value has one and only one output value. Once again, if we apply that vertical line test, where we just throw in vertical lines anywhere on our graph, and as long as those lines intersect only one place for every vertical line, that means it is indeed a function. Okay, moving on forward here, take a look at some things here. The first thing I want to take a look at, I'm going to move myself up a little bit so you guys can see me, is, let's see. All right, let's go ahead and take a look here. So the independent variable is the set of numbers considered to be the input values. Those are everything that we're going to see along the x-axis here. So anything that's along the x-axis, that's considered our independent variable. On the other hand, our dependent variable is everything considered to be the output value. So everything on this vertical y-axis here. Okay, that's super important for us to know here. If we're going to set numbers to represent these, those would be considered our domain and range. Okay, so in this case, if we look at the domain, which is everything between 0 and 1,250, that means that those are all my possible values for the domain. There's no gaps, there's no jumps in the domain here. So we would consider my domain to be every number between 0 and 1,250. And we could also look at the range, the y values, as every value between positive 10 and positive 111. I'll move myself over here so you guys can see that. Okay, so we can represent these using compound inequalities, which looks like this. Okay, so the domain or independent variable can be represented using the compound inequality. 0 is less than or equal to x, less than or equal to 1,250. And then the dependent variable or the range can be represented using the compound inequality at the bottom there. 10 is less than or equal to y, less than or equal to 110. All right. Once again, just like we saw in the previous unit, those just basically mean every number of x between 0 and 1,250 and every number of y between 10 and 110. Okay, that's all that means symbolically here. Okay. So a couple more things I want to take a look at are the different types of points we have, which is 1, 2, 3, 4, and 5 here. So those points that we see along this curve. First thing we're going to define is my y-intercept. Then we're going to look at absolute maximums, relative maximums, and then your relative minimums, as well as your absolute minimum, which is at the end of the graph here. First thing is this y-intercept, this point right here. What that y-intercept is, all it really tells me is that this is where the function intersects with the y-axis, this vertical axis right here. All right, that's the point right there that intersects with the y-axis. In this case, it's going to be 0, 10 is the ordered pair here. It's always where x is equal to 0. All right, so 0, 10 is my y-intercept. The absolute maximum is this value right here because it's the highest point in my graph. It's the highest y value. So my absolute maximum is the point 250, 110 right here. And we want to look at it as what's the y value at this point. So the absolute maximum of the graph would be the value 110. Whereas the relative maximum is a high point, but it's not the highest point on the graph. Okay, so in this case, we would look at this as a value of probably about 90 that would represent all of that. Okay, looking at relative and absolute minimum, we look at the low points here. where we have 1 point right here. Once again, it's a low point, but not the lowest value of our function. That goes to this guy over here, which is about 10, maybe a little bit more or less than that. We really can't tell because there aren't grid lines here. The y-intercept would also be considered an absolute minimum because it looks to be about on the same line or as the point over here. Okay. Looking at another value here, another graph. Let's say we simplify this up. Let's say we have, instead of a curve, we have a straight line here. So what is, I'm going to move myself down here so we can see this question, what is the set of numbers that represents the domain? Okay, once again, it's all my x values, which are everything right here. So between 0 and 200, we would say that, you'd say this compound inequality here, 0 less than or equal to x less than or equal to 200, represents the sets of numbers that are in the domain. Looking at the y values to represent the set of numbers that are in the range, it goes from 0 to 175. So we would say 0 less than or equal to y, less than or equal to 175. And then the y-intercept is just so happens to be where the origin is. So the y-intercept is just the point 0, 0. Referring back to this graph again, the absolute maximum of the graph can be found at the high point here. The absolute minimum of the graph can be found right here. And then what do the points mean in the context of the problem? So here's how we figure this out. The absolute maximum is that red dot right there. It's found at the point 200, 175. But we want to focus on the y value of this. So we would say my absolute maximum is 175. Whereas the absolute minimum would be this blue point right here, found at the point 0, 0. And how we would answer this is, we'd say the absolute maximum is 175, and the absolute minimum is 0. Now, what these points mean, we have to look at these axis labels here, okay? And we're looking at another roller coaster ride. So what we want to think about is, okay, so the distance along the track is for my x, and then the height above the ground is my y value. So at 0, 0, my lowest point here, I'm starting at the bottom of this hill that goes up right away for this roller coaster, Cougar Mountain. So at 0 feet along the track, I'm at 0 feet above the ground. Whereas at this absolute maximum, at 200 feet along the track, I'm at a height of 175 above the ground, 175 feet above the ground. So that's what that really means there. Looking at a different kind of graph. Now, before we saw a bunch of points connected by curves or by lines. In this case, we have 5 points on a graph, not connected by anything. They're just simple, disconnected points. All right, so 1, 2, 3, 4, and 5, like this. This is what we consider a discrete function or discrete domain, okay, where we can list all the points in the function without any gaps or with all these gaps in between, whereas everything else was connected, which we would consider a continuous domain, okay? So because we can list these ordered pairs, that means that we can have this as our domain and range for the function. Okay, so listing all my x values of these ordered pairs, listing all the y values, those would be my domain and range. One last thing I want to point out is, let's say we have a graph like this. You say we have a friend Tom that goes along for a hike, and he hikes along a circular trail known as the Juniper Loop. The graph shows his distance d from the starting point after t minutes. So instead of x and y, now we're using d and t here, okay? The domain and range of Tom's hike can be found, once again, domain is all my x values. It's continuous because all these points are connected. So it would be all these points in orange here. Same with the range. The range would be all these points, all these values between 0 and 7. So we would represent that as a compound inequality. 0 is less than or equal to t, less than or equal to 165. My range is 0, less than or equal to d, less than or equal to 7. But notice how these represent two different things. The domain is in minutes, and the range is in kilometers. Okay? And then the absolute maximum of this graph is this segment right here, which is basically the absolute value is going to be 7, and it represents, if we kind of follow along here, it looks like Tom goes farther and farther away from the start point. He stops for a little bit because he isn't moving. He just stays at 5 kilometers away, and then he walks again, hikes again, and then he gets to 7, where he's the farthest point away. And then everything after that, he gets closer and closer and closer without stopping. So that means to me that that absolute value I can go back. That absolute maximum is the farthest point away where he stops for a couple minutes before he heads back to the trailhead. Looking at the absolute minima, which are these 2 points right here, they are 0, 0, the lowest point are 0, 0, and 165 and 0. And they basically just represent two things. They represent where Tom starts and how long it takes him to get back to the beginning. So in this case, we can say, okay, if he starts at 0, 0 and ends at 165 and 0, that means it takes him 165 minutes to get to where he needs to go. So with all this, your homework can be found on our classroom pages. So 6.1 practice on page 86 in our Springboard books, numbers 25 through 30. And then you also have homework on quizzes, which should have been posted earlier today. So make sure you have these questions answered for me. You can redo the quizzes as often as you want before it is due. So make sure you are trying those questions as best as you can. Hope you guys have a great day. We'll see you next time.